SwayamPrabha. Digital India. Educated India.
In our last two lectures, we discussed two very interesting case study, the Leaning Tower of Pisa and the York Minster foundation repair. And in that process, we have seen how the diagnosis is very important before some sort of intervention is taken in the historic place. Today, we will talk in general about some of the maintenance and repair methods and some guidelines, and in particular some cases of India in a nutshell, so that you have an understand that even when the diagnosis is done and the type of decays what we have discussed about and what can be done. We of course, we are not able to discuss in very much detail, but it will give you some idea that what are the general maintenance and repair methods, and then one has to talk that in very specific nature there is a very wide scope of doing that. So, it is just a general idea about this. So, our topic today is the maintenance and repair. Now, when we talk about any historic structure, there are two parts of the historic structure. One is the superstructure, that what we see above the ground, and the other is the substructure, which is below the ground, generally the foundation and others, but foundation means the foundation with other things. So, substructure means the foundation types of the material, the ground strata and the groundwater and the soil type. All of these very important to understand, for even if you try to understand that what is happening to the substructure, because whatever the if a crack or the signs of decay happen, it happens in the superstructure, but sometimes the causes, as we have seen in both the cases of Leaning Tower of Pisa and York Minster, actually the problem was there in the substructure. And then of course, we have to see that what can be done about that. So, we have to remember these two parts, and they are very integral, and until and you can imagine that when we are talking about a historic structure, understanding the substructure is not easy, because it is always covered. Sometimes there are development around the structure. So, how do we understand that, and how certain type of mitigation measures have to be taken? They are very important part of understanding any repair measure. Now, one thing we must understand when you are talking about the substructure is the principle of foundation behavior in a nutshell. Now, if there is a settlement which is generally manifested in terms of crack, if there is a settlement, we have to understand what is the nature and significance and effects of the settlement. So, generally there are three types of settlement, broadly the three types of category. One is the uniform, that when the entire structure settles uniformly and then straight down, and then there is a tilt when the settles intact, but on an angle. So, there is not much. What is then it can be done that a non-uniform settlement, the settles at a varied angles. In case of York Minster, it was that differential settlement which was diagnosed as the major cause of the settlement. So, it also must important that no foundation carries load without settling. There will be some settlement, but all settlement is not very dangerous, because there will be some adjustment. The uniform and tilting, generally there is not much a problem. The problem is that non-uniform settlement, which is actually manifested in terms of cracks, and if that continues, as we have seen in the case of York Minster, then absolutely it is very important that some measure has to be taken to prevent that. And also that non-uniform settlement what we are talking about, it causes the most stress on a foundation structure. Even in tilting also there can be the cracks and other thing. Uniform, sometimes there is a horizontal crack, but if it is no longer continuing, it probably is not problematic until and unless it settles so much that there is a, from the surrounding ground, there is a lot of problem of the water. But anyway, the most important or most dangerous, should I say, the non-uniform type. And as you can see that if you try to study the nature of the cracks, and that cracks will tell you that what is the problem. In this case, as you can see that there is a steps like crack. So, that generally indicates generally a typical foundation settlement crack, and it also depends, as I say, foundation and the clay all are very important factors which can cause to that cause. One has to understand that what is the factor which causing that settlement and the crack. So, let us see what are the factors which is governing the foundation behavior once we talk about the substructure. One is the load from and the nature of the superstructure. So, sometimes there can be a load which is coming from the superstructure, the foundation, as we have seen in the York Minster also, the foundation itself there was a problem. It was not even in the Pisa also, Leaning Tower of Pisa also we have seen that there was initially it was not designed properly. So, the load from and the nature of the superstructure, that also can be a factor which is causing some sort of a foundation problem. In this case, as you can see that there is a temple, a small temple, there is that step type of crack, but one of the thing it can be a settlement, but also what has happened in this particular case is that there is a huge tree which has grown over the things and it is causing a problem, and there is a crack developed and structure is almost it is a major problem that structure is facing, but it is basically due to the superstructure. Not initial design, but some problems which has happened. The second is the nature and dimensions of the foundation, that how the dimension, and sometimes what happened in historic structure, initially it was designed as a small structure with some sort of foundation, and then there were certain additional parts which have come or additional floors which have been built on it. So, that it may cause some sort of a problem. So, the nature and dimension of the foundation is not able to withstand that, and this is also very important aspect. The nature and history of the ground strata, the soil or rock under the foundation. What is the soil condition, what are the types of soil, what is the layers of the different strata, that is one, and also the history, because there may be some sort of like we have seen in the Leaning Tower of Pisa that the groundwater was being excavated and that caused some sort of a disturbance in the strata, and that caused or enhanced the foundation problem. So, the nature and the history of the ground strata, what it is made of, what is happening, what are the surrounding condition, where there has been tunnel or the groundwater excavation going on, extraction was going on. So, all this is important to understand. In this case, as you can see, is that original heel slope, and then the settlement crack is typically wider at the top. This is also one of the thumb rule, that it's wider at the top, and then you see that this is a fill up area which has happened there, and this fill up area is actually there is a difference between this soil and that soil, this filled up area, and that is causing some sort of a problem, and exactly there you see that crack is happening. So, and there is a surface water runoff which often causes a problem. There is of course a sloping scenario, but it also can happen in a horizontal ground level on a flat soil, where there can be a difference and some sort of a intervention has happened, where the ground strata is changing in its behavior, and that is causing a problem of the foundation. Here again you see that this is this type of crack, what we have seen that it has happened, and this is happened in a very structural failure, and which most probably, and one has to sort of do some sort of a carry out some sort of an investigation and to see that what is the actual reason. But this is the initial signs, and again I mentioned earlier that one has to ascertain whether it is a live crack or whether it is a dead crack with a continuous monitoring. The groundwater, this again and again I am saying that the groundwater, the change in the groundwater level, especially in an urbanized area which was earlier not so urbanized, and development is happening and the deep tubules are being there. So, the change in the groundwater level, that can cause a problem in the fluctuation of the groundwater level, can cause a change in the behavior of the foundation. And any interference after the initial construction, any of this 1, 2, 3, 4 is a combination of that can cause. So, these are the major factors which govern the foundation behavior. and we have to remember some of the thumb rules, what you have seen, that nature of the crack and other things in a nutshell. Now, when we are talking about the ground strata, the nature and history of the ground strata, we have to understand that there are different types of soils, and different types of soils have a different type of behavior and the difference in their bearing capacity, and these need to be understood and in relation to the type of the structure. And so, let us see what are the major types of ground strata which can happen. One is rock. Now, rock generally there is not much of a problem because its bearing capacity is more, but also it is a general statement. There are different types of rock can be there, and depending on if it is a limestone or the different types of sandstone, these will behave in a different way, and they can be having some sort of a decay because of some other factor. There can be mining subsidence, there can be the calcareous material which is soluble in the water, and without saying that there can be the large holes which can develop, understand. So, rock we cannot just say the rock is generally is not a problem. There are problems depending on the which type of rock, and there is sometimes a different combination of the rock strata which can create a problem. But generally the rock is not that much of a problem. The second is the gravel and the sand. Now, when we talk about the gravel and the sand, and then there is a clay and there is a silt, there is a four broad categories of the ground strata which can see. Now, when we can talk about, we are talking about the gravel and sand. Now, it is basically the difference between the grain size, where the gravel is 2 to 3 millimeter and the sand is 0.06 to 2 millimeter that the gravel size. Otherwise, in behavior wise they are more or less same. It is the difference in their size which makes the difference. Now, what is that behavior? Now, behavior is that when compacted and moist with the gravel or sand, it holds together fairly well, but good soils to support a foundation because of their non-water retaining properties. But the problem is that gravel and or sand, their carrying capacity comes from their friction, and so when it is moist, the particles lose their sort of frictional quality and can be washed away, leaving gaps beneath the foundation. So, that becomes a problem, that the water actually acts as a sort of a lubricant, and it that when it loses the friction, then their capacity to bear a foundation becomes a problem. This is the general thing, and there are much more in detail analysis which has to be done. So, when we are talking about the third one, which is the clay and silt, here the bearing capacity, it happens because of the pores within the clay, and the water which comes within the pore, and the pore pressure develops. This actually gives the bearing capacity, and when the clay is squeezed, then the water goes out, there is a pressure which develops. So, the structural engineers are very helpful in making us understand that what is happening in that ground behavior. So, clay are basically tiny particles. It stores water well because of the pores within the clay, and it expands greatly when moist. So, when it behavior changes when it is moist or when it is dry. So, when it expands greatly when moist and shrinks significantly when it dries, so you can see that when it is dry there is it's a crack which has developed, and when it is moist. Now, what happens is that means there is a change in the pore, the pressure which developed because the water which is retained, or if there is a pressure which is coming, then the water is going out of the pore. So, the bearing capacity changes. So, that makes a difference. So, when moist, it is very pliable and can easily be moved and manipulated, but when extreme changes put a great deal of pressure on the foundation, causing them to move up and down and eventually crack, making clay a poor soil for support. And there probably what you need is the different type of foundation, and if that is not there and originally it has not been built, then some sort of a problem can happen. So, each of the soil needs a different type of foundation, they have a different bearing capacity, and the changing the ground structure or the water level acts differently to the different types of soil category. Now, this is very, very nutshell. I mean, as I say, that much more elaborate discussion needs to understand that the behavior of the soil. Now, if there is a problem, whatever the reason, that has to be diagnosed first, but then what are the major ways to mitigate or strengthen the foundation? So, one is soil improvement by grouting, like we have talked about the grouting, the consolidation. Even in the Leaning Tower of Pisa, if you remember that the grouting was tried at one of the stage, but it did not work much. And but the grouting is can be one of the method of foundation strengthening. Underpinning is that, like in this case, what you can see is that there is an original foundation and which is not able to carry, and new sort of a foundation which is under the foundation has been built up. And you can see that here, within that you can see it is a view from the top, that when a concrete foundation is built under the structure, under the original foundation, so that take that extra load. Now, try to imagine and that there is already a structure which is there, and sometimes it is a huge structure, and to build or underpinning is not a matter of chew. It requires a much more expertise, a lot of effort, understanding and how it will be done. We have seen York Minster, it's a underpinning, but it is also pre-stress underpinning was done because of the chart. But underpinning is one of the way where we can strengthen a foundation. And conventional bore piles. So, piles also can be done, that when you put the piles under, it can be piles through the structure and other. In this particular case, what you see that the new sort of a bed has been prepared, and this is now supporting on a, this is a symmetrically balanced one. It sometimes can be an asymmetrically balanced, that the piles can be on one side, two piles, and then it can sort of new structure can act as a cantilever and then support the foundation. So, depending on the situation, these possible, the pile and this beam can be a possible way. So, and there is also a question of mini piles. Mini piling is that when the piling is done through the foundation, cross piling and other. So, boring the holes and then putting concrete into that with the proper reinforcement, so that it can take the enter. If you remember the various options which came for the Leaning Tower of Pisa, there were many such sort of suggestions which were given for that. And foundation strengthening. So, one thumb rule is that either you can go below that which is underpinning, or sometimes you can go wider. So, that you take the foundation, you can go wider. This is the case from Fort William in Calcutta, where there was a serious foundation problem, and then in that case we did the foundation strengthening by the lateral extension, keeping the original foundation and putting it. So, the bearing capacity increases, and it has to be done in phases. They are very challenging task, and these are the major ways the foundation strengthening can be done. Now, let us go to some other aspect, which is the masonry material. We have talked about the substructure, let us talk about something about the superstructure. The masonry materials, as per the original construction detail of the historic building, we have to understand that what is their property, what is their decay. We have taken something earlier. Let us see some aspects of that. Now, let us talk about one is the stone, and stone can be of different type, different categories, of the different ways they can be, the bonding can be different. So, stones again is one of the major, another is the brick. Brick also there is it's a modular things, which is earlier historical time the brick dimension was different, and now the brick dimension, they are also machine made bricks. But when you are talking about historical building, bricks are one of the major material for the masonry structure. Wood, there are places that where the entire structure was built out of wood. In our India, the Padmanabhapuram Palace is one such example, where the walls, the roof, floors, structural members all were made of wood. It has its own challenges, own properties, own beauty and own value and significance. And metal. Metal in these cases, as you can see that it is a sort of a metal which is holding the structure, metal columns, metal beams, the metal finery details which are there. And again, for each type of metal, it will decay in a different way. There are the different properties for that. It can be used as a main structural material. Sometimes it can be used for some of the smaller details or ornamentation. So, metal members is another one. And adobe, if you remember Shamoli is an adobe structure, and many in African countries and other, there are a lot of adobe structure. There are high-rise adobe structures. It has its own properties, own way to decay or one way to sort of resist the decay. It's a traditional knowledge. So, this modern adobe also is another type of material which is used for the superstructure, and a variation of that is the terracotta. We have seen a lot of example of terracotta. Terracotta is the burnt adobe. So, its properties are different because when it is burned at a very high temperature, the silica content within the mud, that sort of gets hardened, and it gives a lot of water resistance and a very hard material, but before burning it can be sort of treated, molded, different types of decorations can be done. That we have seen the Bengal, a lot of these terracotta temples, there is a unique styles and others. So, terracotta tiles or terracotta is a bricks of terracotta which were burnt later on, brick in a way also there. Terracotta is another one where a lot of decorations were done. So, stone, brick, wood, metal members and the mud and adobe, and there are subcategory, they are used in combination sometimes. So, these are some of the major masonry materials which we see. Now, whenever, just this is to remember, when whatever the material we are dealing with for a historic structure, what are the qualities which has to be checked for the material. So, let us go quickly. The material composition, chemical properties, the mechanical properties, color, texture, grain size, compatibility with historic materials, binding characteristic, porosity, presence of harmful materials, source of the materials and economic viability. So, even within each of these broad category, there are a lot of variations, and depending on the place, when it was built, how it was built and how it has decayed, this has to be seen. So, these are some of the sort of a checklist, that what are the qualities of the materials which have to be checked when we are trying to take care of the historic structure. Now, when some of the questions or the characters which had to be examined when we are talking about, first let us talk about the stone masonry. As I said, that stone also there are varied types of stone, one has to take much more detail. So, let us see, there are broadly igneous, sedimentary and metamorphic rocks, and under that there are basalt, granite, sandstone, limestone, marble, and each of them under a different family or a different category. Their property, their behavior and their looks and aesthetics, everything is very different. So, now when we are talking about the rocks in broad, and then we have to know that which type of rock, which characteristics are there. So, the question of characters which has to be examined for doing the rocks is the type of the stone, the place of the origin, the geological nature, grain type, placing, how they were placed in the structure, solubility in the water, surface finish, strength, absorption characteristics and pore system. Even under the same family or same type, there can be a variation depending on which quarry is coming from or where it is coming from, the color, texture, porosity, the grain size, there can be a lot of variation. So, this has to be understood properly with the proper expertise or taking the advice of the experts. Now, when we talking about the stone masonry, whatever the type, we have to understand that basically what is the purpose or what should be the care should be taken is the stabilizing and preventing or retarding further deterioration. This is most important factor when we are talking about stone masonry in any historic structure. Cleaning, that how it should be cleaned, this is also it varies from stone type to stone type. Replacement or substitution, we have discussed that, we have seen in Konarok that the original stone they were not there when it was being built up to the foundation. The anastylosis, I said that when the stones were put up to build up to a certain height, there it has been replaced, and so there has to be some sort of an harmony or compatibility, not only look wise, but composition wise it also has to be seen, otherwise they will behave differently with the temperature fluctuation, with the rain, their behavior will be different. So, it is very important to take the similar type of stone with the same type of characteristics when you talk about a substitution or replacement. Dismantling and rebuilding. So, this is also sometimes what happen in the stone masonry, that it has become so deteriorated, or there is can be a tree which has grown up there, some reason is there. So, we have to dismantle and you have to rebuild that. There are possibilities, probably the joining or the pointing has become loose, or there is some other factors. So, as you can see, this is one from Bhubaneswar, a small temple where the numbering has to be done, it has to be properly recorded, and then it is dismantled and then it can be rebuilt. So, these are the some of the characteristics when we talk about the conservation of the stone masonry. And repair, different types of repair, what is required. Now, when we talk about the cleaning, it depends on that what is the material, is a limestone or is a marble, it is sandstone or granite, depending on the cleaning agent should be decided accordingly. It should be non-ironing detergent, not the normal detergent what we use at home. Removal of the moss and lichen, this is a part of the cleaning process. And cleaning, the other thing which is happening is the cleaning, if you we have discussed when we discussed the decay, that efflorescence from masonry, the removal of the salt, which is very important. And what is the method for removal of the salt? It is a prolonged washing with the fresh water. The water should not contain any chemical or any other types of things or any salinity, and repeated application of the moist paper pulp. This is a method which has been used even in Mahabalipuram, it has been used in the Konark Sun Temple, because it is a porous building material. When you repeated application of the moist paper pulp on the surface, it sort of extracts the water and along with that the soil, the salt in the water, and that is one of the process of removal of the salts. Now, poulticing, we have talked about the poultices, which is a fuller's earth which is kept on the surface, and it also helps in removing the grease, stain and other. Taj Mahal, Agra, this is what happens. So, the poulticing, the moist paper pulp, it also depends on that which is the stone category and what type of decay damages or what we are trying to clean, that is very important to understand. So, these are generally very well known methods. Now, when we are talking about a repair, apart from the cleaning or salt removal of the salt, there is one particular type of repair. There are very many ways of repairing. One particular type of repair is that which is plastic repair or dentistry. Let us see what it means. You can see here that this is a sort of a part which has sort of a decayed, and this part has been sort of repaired here, and this repair is a mortar or a synthetic resin has been done, is a composite mixed with stone dust and other materials to form a stable patch matching to the original color and texture. So, this is a sort of which we call plastic repair or dentistry, or to a historical structure to keep it like that, and some sort of a composite material. What is that and how it is, because sometimes wrongly we used a lot of cement in that, and then we see the cement is a stronger element. It may initially look good, but it sort of ultimately the compatibility is not there, it falls, and in that process it can take out the original material. So, even if you do the plastic repair or dentistry, one has to be very careful what is the method, what type of mixture, what is used, and has to be done. A lot of skill is also required for that. Another thing about the water repellent, because that is a problem, but generally it is not advisable, because whatever water repellent has been used, it in a long term it is not a good thing, it causes further damage. But hopefully with the technological improvement, like with nanotechnology and other, there are different types of technology being improved, which water repellent qualities it has, depending on some of our natural phenomena we have read it, and perhaps there will be a time coming with a lot of interdisciplinary research and other, when we can find out some water repellent which does not cause decay to the existing structure. So, this is something of the stone and some of the ideas about the repair and maintenance. We will continue in our next lecture with the brick and pointing and mortar joints. Thank you.